Hey guys, this is Miss Mo. Let's see, this is the final exam review, and let's go ahead and jump to number 16. Remember that we're not going through every single one of these problems, just the ones that match what's on the final. Okay, so for number 16, it's talking about properties, and some of us are having difficulty with those, but remember that associative means that the parentheses move. Okay, and another way of saying parentheses is brackets or squiggles. Okay, then there's commutative, where the numbers move. Okay, so let's look at this example. Let's check out our numbers. We have 459, 495. What? The numbers moved. So that's commutative. B. And if you look at your parentheses, or in this case, their brackets, the brackets did not change. They're still around the 5 and the 9. 9 and 5. So the brackets did not move positions. If it was associative, the brackets would move like around the 4 and the 5. They would literally move places, but they did not. Okay, let's look at number 18. It says round to the nearest hundred. So we have ones, tens, hundreds. So this is the spot that I'm going to round to. I'm either going to have 5400 or 5500, but either way, this 26 is going to become 00 according to what we see. So I want to look at the number to the right of the hundreds, and I see that it's 2 or less. So I'm going to let that 4 rest, and it's going to become 54. And then everything after it is 00. All right, let's move on from number 18. Let's go to number 21. Number 21 is talking about a designer. It says a designer has designed different tops, pants, and jackets to create outfits. How many different outfits can the models wear if she has designed the following pieces? 3 tops, 4 pants, 5 jackets. Okay, I think this has been on a test. I think maybe all 3 tests accidentally. But you just multiply these together. 3 times 4 times 5. And that makes 60. Woohoo! Okay, the next one we're going to jump to is number 23 on the review. It says, write the complete fact family for 72 divided by 8 is equal to 9. Well, that means that backwards of that is true. 72 divided by 9 equals 8, which is right here. Okay, and then we already have a 72 divided by 8 is 9. Okay, and then what other multiplication facts can we come up through this? We can say that 9 times 8 is 72, or 8 times 9 is 72. So L and A. And then all these other suckers, if you put them in the calculator, they're wrong. Like this part D, it says 9 divided by 8 is 72. 9 divided by 8. No, it's not. Okay, so that one's out. Part G says 72 times 9 is 8. No, it's not. So that one's out. J says 72 times 8 equals 9. No, it's not. It's 576. So on this one, if you're desperate, just go through and do every single problem. 8 times 72. This paper says it's supposed to be equal to 9, but my calculator says it's 576. So that's not the right answer. So on number 23, if you're desperate, you can just check your answers using your basic calculator. Okay, the next one we're going to do is number 24. Okay, number 24 says, is 32 divisible by 4? Okay, the easiest way we can do this is say 32 divided by 4. Oh, it comes out a whole number, so that means, yes, it's divisible by 4. If I would have gotten a decimal, it would not be divisible by 4. Okay, number 25. Number 25. It says place a digit in the square so that is divisible by 4 and 8. Okay, so we're going to try putting a number in here so that I can be divisible by 4 and get out a whole number. So we can just play around if you want to. First, you can try 0. So 967502 divided by 4. Ooh, that gave me a decimale. Not what I wanted. So let's try putting a 1 in here. 967512 divided by 4. Ooh, whole number. Nice. So a 1 worked. Okay, now let's try the same thing, but now we have to be divisible by 8. 8. So first, let me go ahead and throw in that 1 again. Or we'll start with 0. Make it easy. 967502 divided by 8. Nope, that's a decimale. Let me put a 1 in here. Divided by 8. Ooh, that's a whole number. Okay, so I could put a 1 in both of those. And you don't have to put the number that I put. If 7 works, then your test will count it right. If not, I'll go back and look at it. Okay, the next number we're going to go to is 28. 28 says find the prime factorization of 980. So that's where we draw, we're on number 28, prime factorization. This is where we draw that little factor tree. So it doesn't really matter what you start with. I could have started with 5 and something. It doesn't matter. I just chose 98 and 10, and then let's keep breaking. And then just break down as much as you can. Cross out what has been broken. So 98 got broke, 980 got broke, 10 got broke, 49 got broke. Okay, now let's write what we have left over. I have a 7, and there's 2 of them. Times. I have some 2s, and there's 2 of them. I have a 5, and there's just 1 of him. So now we write it smallest to biggest, like the smallest big fat number. So 2 squared times 5 times 7 squared. And if you look, I left off the 5 to the 1. It's okay if you forget. It's okay if you put it out of order on the test. I'll be desperate and I'll give you partial credit or all credit. Okay, 29. It says test whether something is prime. So I'm just going to go through and see if I can divide 101 by anything. So I'm going to start with 2. I cannot divide it by 2 because it's not even. Let's try 3. Divided by 3, I got a decimale. Divided by 4, got a decimale. Divided by 5, got a decimal. 6, got a decimal. 7, got a decimal. 8, got a decimal. 9, got a decimal. And we usually stop at 11, because once we get to 12, if it's divisible by 12, it's also divisible by other stuff. So anyway, let's keep going. 101 divided by 11, decimal. 101 divided by 10, decimal. 101 divided by, what did I miss? 9? I think I missed that. Decimal. So since we can't divide by 2 through 11, I just went ahead and said it was prime. Yay. Okay, let's go to number 33. And again, we're only doing the ones that will be on your final. So 33, it says simplify. Well, when there's a negative outside of parentheses and a negative inside the parentheses, those two connect to make a positive 1. Or just 1. Okay, 34, we have absolute value bars. Okay, well, with absolute value bars, first you have to deal with the bars. And if we have the bars around anything, it spits out a positive. Yeah. So this negative absolute value 6 turns into negative because it's still there. And then this whole absolute value 6 thing, it's going to spit out a positive 6, as in write down 6. So the bars gave you a 6, but then there was a darn negative on the outside. Poop. And when I attach that negative, I get negative 6. Darn. All right, let's keep going. The next one we're going to do is 36. 36 is about temperatures. It says, in each of the following problems, write a subtraction and addition expression. That means something with a minus, something with a plus. That corresponds to the question, and then answer the question. The temperature is 85 degrees and is supposed to drop to 37 by midnight. What is the expected midnight temperature? Okay, well, part A says the subtraction problem is, well, if we start at 85 and we go down, that means minus, and we went down 37. Okay, we can write that exact same thing using addition, as in saying 85 plus, and then to show we went down 37 degrees, we can say negative 37. And either way, 85 minus 37 is 48. And these are our 3 answers that we're going to type in the box. 6. On part B, make sure you put those parentheses or else it's not right. Okay, let's see. Let's look at actual part B. It says Moses has an overdraft privileges at his bank. If he had $400 in his checking account, so it looks like we started with $400, and he wrote a $440 check, does that mean he gets that much money deposited into an account if he writes that check? No, it means it gets subtracted. It's kind of like you Zelle 440 or you Cash App 440. You lose $440. Okay, so that's the subtraction problem because it has a minus. If I wanted to do an addition problem, I'd say 400 plus, but then show that 440 check as a taking it out, as in it's negative, as a withdrawal. And then either way, 400 minus 440 is negative $40. And that's what should go in our 3 blanks. That's not that crazy. The only thing is make sure you put parentheses or else I'm going to have to give you just partial credit. Okay, the next one we're going to do is 37. It says, if it was predicted that the farmland acreage lost to family dwellings over the next 6 years would be 14,000 acres per year, how many acreage would be lost to homes during this time period? Okay. So we lose 14,000 acres per year. How many years did this happen for? 6 years. So what's 6 times 14,000? Because for 1 year you sold 14,000. For 1 year you lost 14,000. For 6 years, well, we need to do that 14,000 6 times. and it should be 84 with 3 zeros. Hey, baby, so we're just multiplying those two numbers. That's all we're doing. 6 times 14,000, 84,000. Okay, then we're going to skip number 38. You're welcome. Let's go to 39. Some of us got this question wrong on the last test. Okay, it says for 39, write a fraction. Okay, well, let's look at part A. I know it looks like there's 1, 2, 3, 4, 5 pieces, but imagine if this whole figure was made up of these small pieces, how many small pieces would be in there? So let's extend these small pieces. And if I extended these small pieces, you see that there's 4 on top now, there's 4 on bottom, so that's 8 in total. And then how many is shaded? 1. Yeah. So do not just count the pieces unless they're all the same shape, the same size. Let's look at part B. It looks like there's, let's see here, 1, 2, 3, 4, 5. 5 on top, and on bottom there's 4. Well, poop. That's not an even amount. That means these are not the same shape. Okay, well, let's count the shapes that look like the ones that are shaded. So here are the shaded shapes, and there's 4 along the bottom. But now think to yourself, how many of these shaded shapes would be along the top? There would be 1, 2, 3, 4. Okay, now we can see that there's 8 total, and there's 1, 2, 3 shaded. So whatever the bottom is, make sure it's the total possible shaded shape. So that's why we looked at our shaded shape and we extended it, and then we counted the total. Same thing for part B. We looked at our shaded shape and we extended them and then counted the total. Okay, let's look at part C. All these shapes are the same, so it'll be easy. 2 shades out of 8 total, and then don't forget to reduce. I think on your last test, I gave you a little partial credit if you forgot to reduce to 1/4. Okay, this last sucker, first we see if all the shapes are the same size, and they are. And there's 3, 6, 9, 12, 14 of them. But then for shaded dots, there's 1, 2, 3, 4. I think that looks like 5. So 5 out of 14. So the only thing is, on these first 2 questions, make sure you count the shapes that are created by the shaded. So on part B, since the shaded is this bigger square, I'm going to count how many bigger squares are in this whole thing, not the little squares. Okay, let's look